Hi, this is Mrs. Tiglis, and today we are going to talk about unit rates with complex fractions. You've already learned what unit rates are, but what we're going to be doing today is adding in the complex fraction piece. So what is a complex fraction? Well, basically it means that there's a fraction within a fraction. Okay, so as the example listed here, like 20 over 1/2, that would be an example of a complex fraction because there is a fraction in the denominator. So we consider a fraction a complex fraction if there is an additional fraction within the numerator and or the denominator. I think it'll make more sense as we keep going. So the first thing I want to do is write some examples of what complex fractions are. So please be sure that you're getting this in your notes as well. Okay? I'm going to show you several, well, let's see, we'll do 5 examples here as it says. So we could have 1 1/3 over 1/4. That would be an example of a complex fraction. Another example could be 1 over 2/3. In this case, there's an additional fraction only in the denominator. Another one could be 1/4 over 7/10. 18 over 3/4, or 1/3 over 1/4. Okay, there's an infinite number of possibilities, of examples of complex fractions, but these are just a few for you to kind of see what they look like and get a better understanding. Okay, so now let's dive in a little bit deeper here. Questions to ask ourselves about complex fractions. So first of all, what operation does the fraction bar represent? Well, hopefully you remember this from prior units. We know that a fraction always means division. Okay, a fraction is a division problem in disguise. So the fraction bar always represents division. So how would we write a complex fraction as a division problem? Well, I think it's going to be a little easier than you think. It would simply be 1/4, that's our numerator, divided by our denominator, which is 2. Okay, so that's how we set it up. But now we have to remember, how do we divide a fraction by a whole number? Well, we multiply by the reciprocal. Multiply by the reciprocal. Again, this should all be review. We've already done this, but sometimes it's kind of, when you see things in a different way, you have to be reminded of how to do the work again. So the reciprocal of 2, remember reciprocal means we flip it over. So any whole number we could write with a 1 underneath. So the reciprocal then would be 1/2 because we have to flip it over. Okay? So now let's go ahead and try one. Okay, so right here we're going to try to simplify 2/3 over 6. All right, well, we know that that means 2/3 divided by 6. We can also write that as 2/3 divided by 6 over 1. Anytime we're dividing fractions, what we do is our first fraction stays the same. We change our division sign to multiplication, and we take the reciprocal of the second fraction. Now don't forget to cross simplify if we can. So if we look this way, we can see that 2 can go into both 2 and 6. Sorry about that. So 6 divided by 2 is 3. 2 divided by 2 is 1. So now our new problem would be 1/3 times 1/3. We multiply straight across, and we would get 1/9. Okay, on the next page here, it says it's your turn to try some. I know we only went over one example so far, but because this is review, I'm hoping it comes back to you pretty easily. However, if it doesn't, you can go ahead and watch this. Otherwise, what I'd like you to do now is pause the video, try these 2 problems, and then come back and watch them to make sure that you did them correctly. I'll give you an opportunity to pause now. Okay, let's see how you did. So if we want to simplify 4 over 1/5, the first thing that we have to do is write it as a division problem. So I'm going to write 4 over 1, our numerator, divided by 1/5. That's the same as 4 over 1 times the reciprocal, which would be 5 over 1. We cannot cross simplify here, so we're going to go ahead and multiply straight across. 4 times 5 is 20, 1 times 1 is 1. Our final answer would be 20. Okay, the second one, again, we're going to take our numerator, which is 2, or 2 over 1. The fraction bar means to divide, and we're going to divide that by our denominator, which is 2/3. Okay, so 2 over 1 divided by 2/3. What we're going to do is change our division sign to multiplication, take the reciprocal of the second number, and now let's look. We can cross simplify. Both of these would become a 1. I like to make it a little neater. 1 over 1 times 3 over 1. Multiply straight across. 1 times 3 is 3. 1 times 1 is 1. Our final answer is 3. So these are kind of fun because, you know, we look at these problems at first and they might seem overwhelming, and it looks like we have a lot of numbers going on, but when we simplify them, it's already what we've done before, and here in these two instances, we end up with a whole number. Okay, now let's go ahead and take these complex fractions and apply them to unit rates, okay? So let's look at this example. Josiah can jog 1 1/3 miles in 1/4 of an hour. Find his average speed in miles per hour. So the first thing to do with any word problem is kind of dissect it and take it apart. So what do we need to find? Well, let's see. It asks us to find our average speed in miles per hour. So we need to find Josiah's average speed. Okay? And then miles per hour, what does that represent? Well, if we think back to unit rates, I always think of that as how much for 1, right? So how many what does miles per hour represent? Well, that represents what the unit rate is. Okay, so that would be a unit rate. Okay, now what is the complex fraction that represents the unit rate? Well, actually, let me not move it up here. So this was 1 1/3. That would have to be our numerator. We don't have a lot of room here, so I'm going to write it like this. That's going to be our numerator, and I'm going to make sure to include my units because that helps me keep everything straight. So 1 1/3 miles per our division line here, our fraction bar, and our denominator is going to be 1/4 of an hour. So that would be the complex fraction to represent that unit rate. Now let's solve it. This is exactly what we've been doing. So our problem now, 1 1/3 divided by 1/4. Well, the first thing we have to do if we have a mixed number is convert it to an improper fraction using MAD. 3 times 1 is 3, plus 1 is 4, so we get 4/3 divided by 1/4, which is going to be the same thing as multiplying by the reciprocal, so times 4 over 1. We cannot cross simplify here, so we'll go ahead and multiply straight across. 4 times 4 is 16, 3 times 1 is 3. So our final answer could be 16 over 3, but that doesn't make as much sense as it would if it were a mixed number. So before we kind of give ourselves a final answer, let's convert this back to a mixed number. 3 can go into 16 5 whole times. Subtract, we get 1 left over. We get 5 1/3. Now again, because we're working on a unit rate here, it's really important that we include our labels. So this means that Josiah can jog 5 1/3 miles per hour. In other words, in 1 hour, Josiah can jog 5 1/3 miles. That would be our final answer. Okay, let's try another one. Tia is painting her house. She paints 34.5 square feet in 3/4 of an hour. At this rate, how many square feet can she paint each hour? What do we need to find? Well, we need to find how many square feet she paints per hour. How many square feet she paints per hour? sorry, that's a little sloppy. What does the number of square feet per hour represent? Again, that represents our unit rate because we're figuring out how much can she paint in 1 hour. Okay, so that means it's going to be the unit rate. So what should we do to find the unit rate? Divide, of course. And what is the complex fraction that represents this unit rate? Okay, this would be 34.5 square feet over 3/4 of an hour. The last thing that we need to do is actually solve it by dividing. So let's write 34.5 divided by 3/4. 34.5 as an improper fraction would be 69/2 divided by 3/4. Then we would write 69/2, change division to multiplication, and take the reciprocal of the second number. We can cross simplify both ways because 3 goes into 3 and 69. 3 goes into 3 once, 3 goes into 69 23 times. If we look the other way, 2 goes into 2 and 4, so the 2 becomes a 1 and the 4 becomes a 2. Now our problem is 23/1 times 2/1, which equals 46/1. So this means, with our units, 46 square feet per 1 hour. So in other words, Tia can paint 46 square feet per hour. Welcome back. So this problem says a construction worker is blacktopping a driveway. She can blacktop 35.5 square yards in 5/6 of an hour. So the first thing we're going to do is write our complex fraction like this. And now we have to figure out how many square yards she can blacktop in 1 hour. So we're going to take the 35.5 divided by 5/6. We're going to convert this to an improper fraction, which would be 71/2 divided by 5/6, which then, of course, turns into multiplying by the reciprocal. We look to cross simplify, and then we're going to multiply straight across. This ends up being 213/5, which is an improper fraction. So let's go ahead and convert it to a mixed number by dividing. 5 goes into 213. Let's see, this would be a 4 and a 2 with 3 left. So it would be 42 3/5. And the key thing is to make sure you include your units. Did you guys remember to do that? The final answer is 42 3/5 square feet per hour. Okay, I hope that helps, and I hope you have a good understanding of unit rates with complex fractions. If you have any other questions, make sure you ask your teacher, and you now can go on and complete the note check and the rest of your assignments.